Welcome to my 43rd tutoring session in A-level chemistry. In this video, I'll give a brief explanation about van der Waals forces and the types of van der Waals forces. Due to the exhaustive nature of this topic, I made this video in a two-part series. Please do watch both the videos. Don't forget to subscribe my channel, share, like, comment and watch the full video. What are van der Waals forces? Now, van der Waals forces are weak intermolecular forces that exist between nonpolar atoms and molecules. Now, van der Waals forces, they play a significant role in physical and chemical processes. Van der Waals forces can be categorized into three main types. They are London dispersion forces, dipole-dipole forces, and ion-induced dipole forces. Let me explain the London dispersion forces with respect to helium atom and nonpolar iodine molecule. In the neutral helium atom, you will find the nucleus contains 2 protons and the outermost valence shell contains 2 electrons. We all know that electrons are always in constant motion, and as a result, there is a temporary or momentary fluctuation in the electrons. And this leads to clustering of electrons on one side of the atom, leading to development of a dipole. And we observe unsymmetrical distribution of electrons in comparison to the neutral helium atom. Now the helium atom with the dipole, when it approaches a neutral atom, due to the repulsion between the negatively charged electrons in the outermost valence shell, it induces a dipole in the neighboring helium atom B. Now you have got helium atom B with a dipole and helium atom A with dipole. And this leads to attraction between the two helium atoms with dipoles. And that is how a weak attractive force exists between nonpolar helium atoms. London dispersion forces exist in nonpolar iodine molecules. And a dipole is induced in the iodine molecule due to momentary or temporary fluctuation of electrons. Or can say it is caused due to disruption of electrons. And this in turn induces dipole in the neighboring iodine molecule. And as a result, there is attraction between the two iodine molecules with corresponding dipoles. And that is why iodine is a solid at room temperature. So it is the weak London dispersion forces that holds the iodine molecules together. Now moving on to the second type of van der Waals force, that is dipole-dipole forces. Now dipole-dipole forces, they occur between polar molecules with permanent dipoles, where the positive end of one molecule is attracted towards the negative end of another molecule. Let me explain the concept of dipole-dipole forces with respect to hydrogen chloride molecule. Hydrogen chloride molecule is polar in nature due to the difference in electronegativity values between the hydrogen atom and the chlorine atom. Electronegativity value of chlorine is 3.1 while the electronegativity value of hydrogen is 2.1. As a result, the chlorine atom, it attracts or pulls the shared pair of electrons closer to itself and acquires a partial negative charge. And thereby, the hydrogen atom bears a or develops a partial positive charge. So now we have hydrogen chloride molecule with a permanent dipole. It has a positive end and a negative end. Now the positive end of the hydrogen chloride molecule is attracted towards the negative end of another hydrogen chloride molecule. And this leads to the dipole-dipole interaction between polar hydrogen chloride molecules. Now dipole-dipole forces are generally seen in polar molecules with permanent dipoles. The third type of van der Waals force is ion-induced dipole force. Ion-induced dipole force arises when the ion induces a dipole in the neighboring nonpolar molecule. So ion-induced dipole force is due to interaction between a negatively charged ion and a neighboring nonpolar molecule. Iodine, as I've already mentioned, is a nonpolar molecule and therefore it is insoluble in water. But iodine is soluble in water in the presence of potassium iodide. So the solubility of iodine in water due to the presence of potassium iodide is a very good example of ion-induced dipole forces. When potassium iodide is dissolved in water, it dissociates into potassium ion and negatively charged iodide ion. The negatively charged iodide ion, it disturbs the electron cloud in the neighboring nonpolar iodine molecule, one of the iodine atoms of the iodine molecule, due to the repulsion between the negatively charged electrons between the valence shells. And this induces a dipole in the neighboring nonpolar iodine molecule. And as a result, there is a weak interaction or attraction between the negatively charged iodide ion and the iodine atom bearing a positive charge in the neighboring iodine molecule with a dipole. And this leads to the formation of a complex triiodide ion. Now the triiodide ion so formed is polar in nature and therefore it tends to interact with the polar water molecule. So polar triiodide ion so formed is soluble in polar water molecule. And that is how the non-polar iodine molecule is solubilized in water in the presence of potassium iodide. This is due to ion-induced dipole forces. Thank you so much for watching my video. I hope you enjoyed it and I'll meet you in my next concluding tutoring session.